Hello everyone. So this is the problem from GTA 2026 last week, and this question was asked by one of my students also. So the question is, let R be the region in the first quadrant bounded by the x-axis, the line 2y is equal to x, and the ellipse x squared by 9 plus y squared is equal to 1, and let R dash be the region in the first quadrant bounded by the y-axis and the line y is equal to mx, and the ellipse is this, the same ellipse we have to use. And now the slope of the line y is equal to mx is given m. So they are saying that the region R and the R dash are the same area, so you have to find out the value of m. So I solved this question in my way, and then I also actually did some research, not that much big research, but just I searched on Google, and I found that this question was originally asked in 1994 Putnam examination, and I got the solution there that is actually different from the solution I thought, and that solution was very elegant. You can see the solution anywhere on such platform where the solution is provided. And the another solution also I tried by using the polar coordinate of this ellipse. That is a little bit not so intuitive. But the first solution what I thought of is a very elegant and also very intuitive. So in this video I'm going to present that solution, and I also recommend to watch or just go through the solution what actual Putnam solution they have given. In that solution what they have given, they have scaled the x and the y axis to convert the ellipse in the circle, and from there we can interpret what the slope should come, because in the circle everything is symmetrical, so two lines will actually act as a one single line. So there is another thing we can see, but what I'm going to give that what I thought from the scratch, and it's so intuitive, maybe you like it. So this is the ellipse I have, and they have given there that the line y is equal to x by 2. So let's say the y is equal to x by 2 is a line, because half slope is half, so it's a little bit not so slant, not so steep actually. So which color I use, let's say, so this is the y is equal to half x I'm taking, and let's say y is equal to mx is a line like this. Now what the question is demanding is this one. What they're asking that the area R is this one. This is the region here R, and this is R dash. Look at the solution, look at the question actually. The question says that the area bounded by 2y is equal to x, which is I have written y is equal to half x, and the x-axis and the ellipse in the first quadrant. So this is the region R we have, and R dash is the area by the ellipse and the line y is equal to mx and the y-axis. So that will give you the R dash, and both area should be equal, so we have to find out the slope of this thing. If this area is equal to this area, it means if I drop perpendicular from here to the x-axis and then divide into two pieces, so this area of this angle plus area whatever left over here with the ellipse and this line with the x-axis combinedly give the area of this sector inside the ellipse. In the same way, if I drop the perpendicular from this point to this line, the y-axis, we get this triangle and again this piece. If this total two sectors areas, means total area of the two sectors individually are equal, it means this piece and this piece have the equal area by the symmetry. It should be. And similarly, the area of this triangle and area of this triangle must be equal. So why don't we can equate the areas of these two triangles, and from there also we can find the slope. So for that we have to first find out the point of intersection. Let's say this is point P here, and let's say this point Q. So basically I'm asking the area of triangle OPQ. Triangle OPQ area must be equal to the area of triangle. Let's say this point is M and this point is capital N. So area of OMN. So for that I need to find out the point here, and I'm solving this with the ellipse equation. So what I get it here is x square, and the place of y I'm writing x square by 9, by the way, that is going to be x square. How I've written this thing, half x means this half x. So this is going to be 1 by 4x square is equal to 1. From there I'm getting 13x square is equal to 36. And so x is equal to 6 by root 13. We don't have to bother. Now the y coordinate will get 3 by root 13. So the area of triangle OPQ is going to be, let me cut this thing there. So the area of triangle OPQ I can write as half into base. The base is the x coordinate and the height is the y coordinate. So all that we have to substitute these two values at the base and height. So this will give you 6 by root 13 into 3 by root 13 on the left side. On the right hand side, I am willing to find out the area of this triangle OMN. So for OMN, again, I have to evaluate this coordinate, that is M. So for M, again, I'm going to substitute this y is equal to mx in the ellipse equation. So x squared by 9, I'm discovering M here, and y is equal to mx. So m squared, x squared is equal to 1. So from there, I can get 1 plus 9m squared, x squared is equal to 9. And so x is equal to 3 divided by square root of 1 plus 9m square. This is x coordinate, and of course for the y coordinate I have to substitute this thing there. So we get 3m. So 3m square root of 1 plus 9m square. And again we replicate the same story there. That's a half and the base into height. So 3 by root of 1 plus m square into 3m by root of 1 plus m square. Sorry, 9m square rather. So let me write it correctly. This is root of 1 plus 9m squared, root of 1 plus 9m square. And all that we have to now simplify it and see what the answer is coming for m. So this side I'm getting this 3 and 3 cancelled, and 3 to the 6. So this side I got 2 by 13. And here I'm getting m by 1 plus 9m square. All are simplified version. So let's see now. 2 plus 18m squared is equal to 13m. And so 18m squared minus 13m is equal, plus 2 is equal to 0. So now this is 13 here and 18 to the 36. So I can safely find the factor by 9m and 4m plus 2 is equal to 0. So from there I'm getting 2m, rather 9m common here, and minus 2 and 2m minus 1. So I got two slopes, m is equal to 2 by 9 and m is equal to half. So m is equal to half is already representing one line which is given to us in the question. That is, so m is equal to half is the slope of the line given the question, y is equal to half x. So the other slope should be the slope of different line, that is m is equal to 2 by 9. So in this way, without using the ellipse at all, we are just using our intuition to see that the two areas are symmetrical. So the corresponding angles should be having same areas, and from there we can do it. If you find this solution interesting, you just let me know. And I hope that many of the students have thought like this, and I'm waiting for their responses also. And if you find any other solution, please let me know also. And I also request to go to the actual solution in which the circle scale thing is given, and then you can find the solution. But before that, I request you to please attempt. You have not attempted so far. All right. So this is all for today. See you in the next video. Till then, stay math active.